What's up, everybody? This is the first uh, tutorial on solving problems with the gas laws. I want to walk you through a step-by-step process of using the gas law and showing all the required steps that are needed to get all the possible points if we were going to grade this for accuracy. So these are your 6 steps. Might seem overwhelming, but these will be provided for you on any worksheet we ask you to do. So the worksheet below has this on the top of the first page. You can always refer back to it. The problem set we're going to ask you to do at the end of the week, which will not be graded for accuracy. I just want to see how you guys are capable of working through these problems, solving these problems. I want to analyze your algebra skills a little bit and just see how we do. That'll be a completion activity. We'll get to that later on in the week. So the first step is you always want to list what you're given and what the unknown is based on the problem. If you have temperature, so number 2 isn't always required, but if one of the givens is a temperature, you need to change Celsius to Kelvin automatically. You're going to make a little list of your values. If a temperature is there in Celsius, add 273, change it to Kelvin right away. Use your given info to choose the correct gas law and write the original formula equation. So we went over that in the last activity. You should have gone through that little self-assessment quiz to see if you were able to pick the right gas law based on the problems. If you haven't done that, I would say pause, go back and run through that self-assessment a time or two and make sure you're able to pick the right gas law based on what is given and asked for in the problem. Once you have that equation written down, you're going to rearrange the equation. You're going to rearrange the variables to find your unknown. You can also plug your values in and rearrange them. I think it's easier to rearrange the letters, to be honest with you. It's more efficient. So that's how I'm going to show you. Plug your values in once you rearrange for the unknown, and then round your answer to sig figs. We'll talk about sig fig rules as we go through this activity. So here's our first example, and this is the example that's on your worksheet. So if you want to follow along, please feel free to do that. A sample of neon has a volume of 0.125 liters at 105.0 kPa. What volume will the gas occupy if the pressure is dropped to 101.325 kPa? So they gave you liters. We should recognize that as volume. They gave you kPa. That's a pressure unit. They asked you for volume, which you'll give in liters because you're given liters. You'll solve in liters. Just keep all your units the same. And then they gave you a new pressure at 101.325 kPa. So the first thing we want to do is we want to write down what we know. You can show this 2 different ways. Let me explain why it's best to do it one way over the other. You can definitely label each one in the problem like this. Absolutely feel free to do that. If there's a temperature involved, though, and you have to change that to Kelvin, you're going to have some work you're going to have to show for that. So it is really best to come over just off to the side somewhere, list your variables. You have a pressure and a volume. You have a second pressure, you're asked for a second volume. Notice how these 2 are tied together. It's 0.125 liters at 105.0 kPa. This volume is at this pressure. This is one set of conditions. So we'll write that as volume 1, pressure 1. You can do initial and final. You can do A's and B's, X's and Y's. I don't care how you label them. Make sure in some way, shape, or form, though, this volume is the volume of the gas at this pressure. So those have to have the same markings, V1 and P1. It's asking you what the new volume, what a second volume would be at this second pressure. So list those out. Next, we've got to use what we're given to figure out what equation we need to use. So you'll see over here, we have P, V, P, and V. Sorry, that thing keeps popping up. We have our pressure and our volume, another pressure, another volume. What's the only gas law that we know of? that deals only with P and V. That's Boyle's. So we write down the equation for Boyle's law, P1V1 equals P2V2. This is the next step. Solve for your unknown. They're asking you for volume. So get volume by itself. How do we do that? Well, right now, volume is being multiplied by pressure, P times V. What's the opposite of multiplication? Division. So whatever you do to one side, to get rid of the P here, we divide by P2. Whatever you do to this side, you have to do this side as well. So P1V1 over P2, we'll see that's going to be our new equation. Write the rearranged equation. And then once you get that point, plug your numbers in. You'll see you have where the P1 was on top, we put our 105.0 kPa. Where the V1 was, we put our 0.125 liters. Where the P2 was on the bottom, we put the 101.325. At this point, just do the math. Make sure you're canceling out units. And you get 0.1295. The reason we rounded the final answer to 0.130 liters was because our given values up here, you have 3 digits, 4 digits, 6 digits. We've got to round our answer to the lesser number of significant digits, okay? Now, for each of the gas law problems, I have a worked out example that is color coded the same way on your worksheet. For each problem type, there are tutorial videos that you can watch and go through for additional help. I've linked Mr. O'Reilly's videos that he made. I'm going to put Tyler DeWitt's videos on there for each of the gas laws. And then I'm also going to put Marissa Maribel's on there. At the end, I will put a summary video from Tyler DeWitt that's really good on how do you know which gas law to choose. That should help you with the testable material, which is being able to look at the problem. For instance, you should be able to look at this problem, realize that pressure and volume are the only variables included. So the Boyle's law equation is what you want to use. P1V1 equals P2V2. If you have any questions at all, please email me. Please remember that the problem set at the end of the week is completion. I'm looking to see, are you able to work through the problems, pick the right gas law, just to see how you're doing with problem solving. You're going to take a picture, so you'll have your work like this written out. You'll take a picture of your entire worksheet, and then you'll attach that to the assignment with the directions I'll include. I'll put a instructional video on how to attach them on there. Most of you guys and gals have already figured that out pretty easy. You've sent me some things digitally already. Just take a picture with your phone and attach it. If you have questions on any of this, please email me. Get as far as you can with a problem, take a picture of it and send it to me for feedback, and I'll get back to you. Again, the problem sets are really to help you figure out what gas law should you be using, and then to see how well you are able to work through the problem solving process. You will not be checked for accuracy on the problem sets. This is just trying to see how we do with the calculations. So make sure you do your best, give me your best work. If you cannot print, make sure that you neatly write down the number. So practice 1, practice 2 on a sheet of paper. Write down which gas law problems they are so that you keep everything organized. And then we'll just accept the picture of those when you turn them in. Good luck. If you have questions on anything, let me know. The solutions are provided on this post. So once you get done with a problem, go ahead and check your work. See if you did everything right. See if you included everything. Stay healthy, be strong, get better every day. And please don't hesitate to contact me if you have any questions.